Building a reliable HF linear amplifier, especially one utilizing robust components like the IRFP 150, requires more than just a solid RF deck. The protection circuitry acts as the brain that prevents expensive silicon from turning into expensive smoke. For a 100-watt plus build, you need to monitor three critical failure points: overdrive, high SWR, and overheat. As I have already faced an overdrive problem and luckily escaped without expensive smoke, I am wondering how I can implement the following possible protections. Input overdrive protection. The gates of MOSFETs are incredibly sensitive to voltage spikes. If your transceiver accidentally spikes or you forget to dial back the power, the IRFP 150 can fail instantly. Use a sampling coupler or a simple resistive tap at the input. This RF is rectified into a DC voltage. A fast-acting comparator like LM311 or LM339 compares this sampled voltage against a preset reference set by a multi-turn potentiometer. LM311 is a single high-speed precision comparator, while LM339 is a quad comparator. The comparator output triggers a high-speed relay or an electronic attenuator to disconnect the input or shunt it to the ground. SWR, reflected power protection. If a wrong antenna is accidentally connected, high reflected power creates high voltage peaks at the MOSFET drains, leading to breakdown. A Bruin bridge is an option which can be used at the amplifier output. Bruin bridge is a classic and highly reliable circuit used in amateur radio to measure forward and reflected power. Unlike a simple SWR bridge, Bruin bridge design uses a combination of a capacitive voltage divider and a current transformer to provide accurate readings across a wide frequency range. Forward power and reflected power are converted to DC. If the reflected DC voltage exceeds a threshold, typically representing an SWR more than 2:1 or 3:1, the protection kicks in. This should trigger a latching fault. Once SWR protection trips, the amplifier should stay off until you manually reset it, preventing it from chattering under high SWR. Thermal protection. Since I am working with an aluminum heatsink for IRFP 150s, managing the thermal mass is vital. MOSFETs exhibit thermal runaway if they get too hot, where they draw more current, leading to even more heat. Mount a 10K NTC negative temperature coefficient thermistor or a dedicated IC like LM35 directly onto the heatsink as close to the MOSFET casing as possible. LM35 outputs exactly 10 millivolts per degree Celsius. There could be a two-stage logic. Stage 1 is fan control. At 45 degrees, trigger the cooling fans to high speed. Stage 2, emergency cutoff. At 75 to 80 degrees, the comparator should disable the PTT line or cut the bias voltage to the MOSFETs to stop amplification immediately. VU3GZR has already implemented a thermal sensor cutoff in his build of VU2 EVQ linear amplifier. Essential components for the protection board. To build this into a single supervisory board component, LM339 or LM324, quad op-amp or comparator to handle all three inputs, 2N2222 or equivalent transistors to drive the protection delays, 12-volt DP-DT relay to interrupt the PTT line and or the VCC supply, LED indicators, red for fault, green for ready, and yellow for high temperature. Another option is to ensure the bias circuit is also tied to the protection. If any fault is detected, dropping the gate bias to 0 volts is the fastest way to shut down the MOSFETs while the slower mechanical relays are still moving.